Welcome to The Explainer. If you're a data scientist making that leap into MLOps, there is one skill that's an absolute game changer: reproducibility. It's what turns a really cool experiment in a notebook into a bulletproof, production-ready system. So let's break down how you can master it.
Okay, let's be real. We've all been there. You get a fantastic result, you're excited, but a week later, the exact same script gives you a totally different answer. It's not just frustrating, it completely undermines trust in your work. And that right there, that's the core problem reproducibility is here to solve.
All right, so here's our game plan. We're going to start by defining reproducibility and see how it's different from replicability. Then we'll dig into why it's so critical. After that, it's all about the practical stuff, a blueprint and some code before we wrap up with how you can make this a daily habit.
So, first things first. What do we even mean when we say reproducibility in the world of MLOps? Well, at its heart, it's all about building a foundation of trust.
To put it simply, it's all about getting the exact same results from an experiment every single time. And you'll notice there are three non-negotiable ingredients here: the same code, the same data, and the same environment. If you change even one of those, you can kiss reproducibility goodbye. Now, it's super important not to confuse reproducibility with its close cousin, replicability. They sound similar, I know, but for an engineer, the difference is absolutely critical. In our world, in MLOps, our focus is almost entirely on reproducibility. We're validating the process. Can I rerun my own script with my own data and get the same output? Replicability, on the other hand, is a much broader scientific goal. It's about validating a finding. Can another team with different code reach the same general conclusion? See the difference? To build reliable systems, we have to nail reproducibility first.
So we know what it is, but why does it matter so much? Because in a professional MLOps setting, this isn't just a nice-to-have, it's a straight-up business imperative.
Just think about it for a second. Reproducibility builds trust. It proves your model's performance isn't just a lucky fluke. And when, not if, performance drops in production, it's your absolute lifeline for debugging. It lets you find the exact cause instead of just fumbling around in the dark. Plus, it's the bedrock of real team collaboration. And if you're in a regulated industry like finance or healthcare, it's the core of your audit trail. This really says it all, doesn't it? Reproducibility proves your results are the product of skill, not luck. It's the mark of a professional engineer, not just someone messing around with experiments.
Okay, enough of the why. Let's get to the how. Here's the practical blueprint, your toolkit for getting that consistency you need in every single project.
This 6-step blueprint is basically your road to bulletproof MLOps. Think of it as a maturity model. You might start simple with just versioning your code and setting random seeds, but the end goal is a complete system. You lock your environment, you version your code and data, you control randomness, you track everything, and you automate the whole shebang. These aren't just separate items on a checklist, they all work together.
All right, let's make this really concrete. We're going to zoom in on a couple of these key steps and look at the actual code that makes it happen.
The most common culprit for inconsistent results is randomness. Every time you initialize model weights or shuffle a dataset, things can change. So how do you tame this chaos? You do it by setting a single, fixed number called a random seed.
And here's what that looks like in the real world. We set a seed, 42 is a classic choice, for the nerds out there, for both Python's standard random library and for NumPy. And then in libraries like scikit-learn, you pass this number directly into the functions using the random_state parameter. This one little change guarantees your train test splits will be identical every single run.
Of course, the same principle applies to your favorite deep learning frameworks. For PyTorch, you use torch.manual_seed, and for TensorFlow, it's tf.random.setSeed. And hey, here's a pro tip you can see on the screen. Don't forget to set separate seeds for your GPUs. Using a command like cuda.manualSeedAll ensures total determinism. It's a tiny detail that can really trip you up if you forget it.
Now, setting seeds is the fantastic start, but it really only solves one piece of the puzzle. For true end-to-end reproducibility, you need to package the entire workflow. And that's where a tool like MLflow Projects comes in. It uses a single file to define your project's entire execution.
So the heart of an MLflow project is this ML project file. Let's just quickly break it down. The Python_env line points to a lock file of your exact dependencies. This means the environment is going to be identical every time. Then this entry point section defines the exact command to run your code.
Basically, this file is your project's entire recipe for reproducibility.
And here is where the magic happens. With that one file in place, anyone, you, your teammate, a new hire, can run the entire workflow with a single MLflow run command. You just point it to your project, pass in any parameters you need, and that's it. MLflow takes care of the rest. The whole, well, it worked on my machine problem? Yeah, that's officially solved.
The benefits here are just huge. We're talking automated environments and standardized execution for everyone on the team. At the end of the day, it gives your entire organization a common framework to build, share, and collaborate on machine learning projects reliably.
All right, we have covered a ton of ground: the what, the why, and the how. The only thing left is turning all this knowledge into practice and making reproducibility a habit you don't even have to think about. So I'm going to leave you with a question, a challenge for your very next project. What is the one step you can take today to make it reproducible? Maybe it's just setting a random seed. Maybe it's creating a simple requirements file. The key is to just start with one thing, make it a habit, and build from there.